Hello, everyone. I'm going to demonstrate the execution of 3 attack trees we have built for the QuickStart architecture. At this stage, all I know about the system is a domain name, quicksat.com. I do not have any knowledge of the ground system assets or the user interfaces or the users. Also, I'm 1,000 miles away from the software and hardware. These scenarios are executed fully remotely with no physical access to the hardware or the software. We start with a simple but very real scenario. Here we have the first attack tree for a denial of service scenario, where my objective is to cause annoyance to the system operator or the customer. The attack tree here is built using the methodology that was described previously. This method forces you to think more directly from an attacker's point of view and consider the steps an attacker would take to compromise a system. So here at the top of the tree is my goal, which is to create a denial of service or an annoyance to the customer. I've listed a sub goal for each of the kill chain steps here. It's easy to see that there are many ways to achieve the goal. I'm just demonstrating one of the many ways. So overall, what we want to do is first gather enough information about the system assets and users in the recon step, then attempt to phish legitimate users in order to steal the credentials, then get access to the user interfaces for the quicksat.com, which would hopefully give us access to the CubeSats, and then execute some steps to create annoyance. So when you create a tree such as this, it is not always the case that these steps would be successful. So as an attacker, you may have to test out multiple different ways of getting access to a system. I'm showing you one that worked for me. So most of the vulnerabilities I demonstrate here are real vulnerabilities in the system, which were found while preparing for this demo. Because CubeSat software, both on the ground and the spacecraft, is built using common IT platforms, it is vulnerable to the same kinds of actions that hackers take on regular IT environments. The only difference here is that these CubeSats are in space. So the implications are much more scary. So I'm going to use this popular hacker distribution called Kali Linux. This comes pre-built with a lot of tools necessary for conducting the attacks, and it's freely available. Here on the right-hand side, I have my notes open, so you can follow along. I have arranged these notes as per the steps in the attack tree. All right, so let's start with the first step, Recon. So in the Recon step, I'm going to gather information about the system, the assets, and the users if possible. First objective is to find out the systems to attack. One way to do that is by looking at what systems are registered under the domain name quicksat.com. We use a DNS dumping service for that. It may not give you all the results, but it's a start. So we go to this free domain name dumping service called DNS Dumpster and enter your domain name, search, and then it would list out all the systems that it knows are registered under that domain. So here we see here's an IP address 159.118.1.204. There are some other systems under under Amazon. Let's focus on this one. Okay, so let's start by probing this IP address 159.118.1.204. As you could see, this IP address is responding. Now we could also probe IP addresses around it, as often companies would get allocated a set of contiguous IP addresses. So for example, 202 is alive, 205 is sending, 206 is alive. Now, these may not all belong to QuickSat, but at least it's a start. So what we have here is, so let's start with these 3 IP addresses, 118.202, 118.1.204, 118.1.205. Now let's take a look at what services are running on these IP addresses. We'll use a tool called Nmap for this purpose. So we issue this command called Nmap and run it. It will map out all the ports that are open on that machine. As we see, there are many ports open on this machine. I have the final output here for both these for this machine 202, and also similarly you can run it for 205. Basically, what's of interest to us here is that there are 3 services that we'll focus on. We see that there is port 22, which is the SSH that is open on 202. There's port 80.443, which is a web server, and also port 389, which is LDAP, or a directory service. Similarly, on 205, there is an SSH and a web server that's open. Now that we know what services are running on the machine, let's try to dig a little bit. The next step is to map out any web applications that are running on this machine. For that purpose, I use this tool called GoBuster, which will actually map out if there are any interesting web applications on that machine. So So it uses a dictionary of common words or common applications, and then tries to search this IP address for those applications. It should run pretty quickly. So as we say, it's already giving us some results. So there's something called /auth, which is running on the server. There's something called /change password, which exists. There's info.php, which exists. And now this is interesting. You see that there's something called PHP My Admin that's running. This is a very popular interface for managing databases. And you also have the script called PHP Info.php. Now, as you can see, this is a very interesting script, PHP Info. If this is accessible, we click on it, you see that it dumps a ton of information about the server configuration. And this is, from a security standpoint, this is really bad. From a hacker's point of view, this is a treasure trove of information. So you get everything about what versions of the software is running on the machine, to what the key directories are, and so on, and what's installed, what modules are installed, and so on. So this is a really good find. As we see, this tool gives us a lot of good information. But the one that we'll keep handy is this directory, which is the web server root, where all the websites are stored. Now let's see if we can extract some information about the user from the servers. As you may recall, when we did our Nmap, we found that port 389, which is the LDAP port, was open to the internet. This is a vulnerability and should not be the case. LDAP is a directory protocol which allows organizations to systematically name and manage their assets. We'll see if we can make LDAP reveal information about the users. We first try to run this Nmap command to gather information about how the LDAP directory is organized. This could take a while, but this is basically what it returns. It will return you a list of all these contexts. So it basically shows how the directory is organized. Now, as you can see, the LDAP is storing a ton of information about servers, about users, about groups. So for us, for our interest, we'll query these users. So we could run another command called LDAP search to see if we can actually get that information out. So if you run LDAP search, it succeeds. We get a ton of information out. I'm not going to show you all this information because this is from a real system and there are real users with real accounts. But what's important to note here is that this is another vulnerability that we exploited, because I was able to run this LDAP search without any credentials against this host. From this step, I could gather names and email addresses for two users, Andrew and Aaron. Andrew seems to be someone important at QuickSat, and Aaron seems to be a customer. Now, the next step is to create the phishing email. I can easily learn about both these users from their social media, such as LinkedIn and Facebook. Once I do that, I can craft a convincing phishing email. Here is an example. Note that the link here has a typo, but it is very close to the real site's URL. And also, since this email will go out from Andrew, there is very little for Aaron to doubt about this. Now, the next step, delivery, is the really easy part here. I use an online fake email service, such as this, to send an email from Andrew to Aaron. You can play with the headers to make it look as convincing as you want. And as you can see that this is very easy to do. And let's assume that Aaron falls for this fish and gives me his credentials. Now we move on to the last stage of execution to finally achieve our goal. So at this point, I still don't know where the CubeSat user interface is located. All we have at this point are the user is a username and some credentials. So let's see if we can do a little bit more probing. Let's first try remotely logging into the system as Aaron. We could now try probing the system using Aaron's permissions. Oftentimes, system misconfigurations may allow non-privileged users to read information that they should not be able to read. For example, recall that we had collected this directory about the web server in our initial probing. Let's see if we can actually access that directory as Aaron. So if I just paste that directory, it actually allows me to go into that directory. And if I see here, I can see the entire directory structure. Something interesting I find here is another directory called VMS. So if I go into VMS, sounds interesting. And then it has something called a login page. So let's see if we can actually access that information. So I have it here. So if I click on that, voila, I actually can see what looks like a vehicle management system for the CubeSat with the login and a username. Let's try logging in with Aaron's credentials and see if that works. Now, once I'm in, I can easily spend some time here trying to get myself familiar with the interface. I've already decided what actions I want to take here. The easiest way to annoy a user or to create a simple denial of service is to just change some configuration parameters to confuse the users and to add delete stuff. So let's see if we can actually change some parameters here. For example, based on my expression, I found that there's a syslog parameter here. What it looks like, if I set this to a very low value, it'll make the CubeSat send, say, one syslog at a time. Considering that the CubeSat is in orbit and will only sync once in a while, the user will be able to get only a trickle of status every time it syncs. Finally, another thing I could do here is to just queue up a ton of commands for the CubeSat to execute. This will ensure that the CubeSat is locked up processing my commands and perhaps drop delay estimate commands. So for example, I could just continuously do a bunch of deletes of the same application. This may not do anything to the CubeSat, but it could just make it execute this command, queue up the commands, taking up valuable queue space. So as you can see here, it says pending round, pending round, pending round. I've just been queuing up commands for the CubeSat to execute. So next time it talks to the database, it's going to take all of these commands and then execute them. You can easily imagine I could queue up thousands of commands here. So just to take a step back, what I've shown here is how easy it was for me to piece together publicly accessible information along with misconfigurations and system vulnerabilities to finally gain access to the CubeSat user interface and cause annoyance to the user. System owners and operators should take holistic difference in depth approach to system security. Apply cybersecurity best practices such as firewalling unnecessary ports, maybe enabling two-factor authentication, patching software, and limiting access to users to defend their assets.